Hello everyone, thanks for having me today. In this talk I will show you what to do when your scanner like Trivy or Grype gives you 100 of CVEs in your deployed software. So the plan is to show you the approach and the method to resolve the situation, and then I will make a live demo and show you where it breaks. I am Fahed Dorgaa, I'm a senior software engineer. I focus on vulnerability, I am maintainer of NerdCTL, and I am the creator of vens, the tool that I will show you today. So you all know this situation. When you push an image that trigger your scanner, you get 200 or 300 findings. The real question, which one fix first and what to prioritize? The common move is to pass by CVSS. That means sort by CVSS and start fixing from the top to down based on the CVSS score. But the problem, CVSS score only the flow, not your system. For example, a CVE with a score 8.8 stay 8.8 either your application is internet facing or not, which means unreachable 8.8 CVE may come above a reachable 5.3 CVE, which is wrong. And usually in this situation, teams triage by hand for days or ship and hope, and this is bad. So the missing piece here is the context that will turn severity in real risk for your application. And then once you have vulnerability triaged by real risk, you can fix from top to down with no problem. There is two ways to score CVE. The classic way, the CVSS, as I said before. So score from 0 to 10. Usually every scanner uses it. It describes only the flow and not your system, and this is the big problem that you are facing here. In the right side, we have the OWASP Risk Rating methodology. It's scored from 0 to 81, and this is what vens is using. So vens is using this methodology in order to score CVEs in a contextual way based on OWASP factors. So the OWASP methodology help us creating or building factor by factor based on the context that we'll provide. I will show you later how to do this. This context will contain exposure, data sensitivity, and control. So vens scores CVE barrier risk. The workflow is simple. You generate a report using Trivy or Grype. You create a declared description of your deployment, which is a file. I will show you in the next slide, I think, how to declare your context in config file. You give all of this to vens, then vens will call an LLM to rescore everything in that context and give you a VEX, which will contains every CVE scored by your context, not with CVSS and things coming from vendors from outside. So this is how you declare your context. Let me show you a full example that we have in our vens repository. So first of all, you have to declare your project name and description. Then you have to declare the context. Under the context, you have two types of fields: mandatory fields and optional field. Mandatory, we have exposure, data sensitivity, business criticality, and here we have all the values that can be put for each field. Like exposure, we have internal, private, internet, and the explanation for each field. So I really recommend to visit this page before creating your context. And for optional, the same thing. So we have a lot of fields, and also I also highly recommend to put both optional and mandatory fields if you can, of course, but at least mandatory fields, because when you put both, you have a more accurate result because you introduce more inputs to the LLM to think and give you an accurate result. So the LLM never gives you the final number, and this is to avoid hallucinations. It only fills the OWASP factors, calculate the likelihood and impact for OWASP, and then using the OWASP formula, we produce a score. So this is why vens is deterministic in this part, and this is very important to avoid hallucination, as I said. So if the LLM produce the same factor, you will get the same scores in the output every time. So how it works, you have to generate your Trivy Grype report. You write your context file, the config file .yaml, and then you give all of this to the LLM to score in OWASP frames. Then the LLM, which will be triggered by vens. It will generate CycloneDX VEX that control contextual scores, and another file near to the VEX. It's a sibling document, which called CycloneDX attestation that contain the provenance and the evidence. So it will contain each provenance and evidence and reasoning for each CVE to explain you what happens under the scene and to help you to reproduce things and to debug things in case of problem. So we don't trust VEX, and this is the provenance and the evidence that usually the engineers need to understand what happened under the scene. So vens is not shrinking or suppressing vens or CVEs. It's just reordering CVEs. So before vens, we have CVE of type RC with high severity. We run vens, it rescores in context, and it gives us low. So from high we go low. Why? Because vens discovered that the path for this CVE is unreachable. Good. The second example, we go from medium to high. Why? Because vens discovered that GDPR is not in scope, and this will, help a lot. So vens writes CycloneDX VEX with OWASP Risk Rating, as we said before. This is an extract of how it looks like. We have a JSON with the CVE ID and ratings. The rating block contains the methodology, which is OWASP, the contextual score, the contextual severity, and the vector. And vens, it also provide a sidecar file or sibling document, which is CycloneDX attestation. It contains beer CVE evidence claim, which is the factor behind each score. It also records model, seed, and input hashes for each CVE that will help you to reproduce what you did, and not just trusting the VEX. So the idea of these two files, or the idea of vens, is to provide two files, one that will ship a clean score that you can share with everyone, and another file which is a CycloneDX attestation that contains the evidence and what happened under the scene, that you can keep it in your company and share, keep it private, because it may contain sensitive data. So this is an example or an extract of the CycloneDX attestation. We have the target component, the predicate with the score, the severity, the reasoning, why we have this score, and the evidence that contain the model that generate all of this, the seed, the temperature, the prompt hash, input hash, etc. So Trivy is an official, vens is an official Trivy plugin. It is listed in the official Trivy plugin index Aqua Security. If you already use Trivy, no separate binary to manage. You just launch Trivy plugin, install vens, and you will install vens as Trivy plugin. And once installed, you can call it through the Trivy binary. So for example, to generate a report JSON from your config file, you can make Trivy vens generate. You pass your config file, the report, and it will generate the VEX with contextual score. We also created a GitHub action for vens that will help you easily integrate vens in your pipeline. Let me show you the repository. So this is the repository. We have everything to set up the vens action with the fields that you need, for example, the version, config file, the LLM, etc. And if each field is explained. Yeah, by the way, in our organization, we have vens action here for the GitHub action, and we have the vens repository that contain the vens binary. So go back to the presentation. Yeah, so in the demo, I already prepared the demo. I made a GitHub pipeline that will scan a Python image, then it will start Olama. Then it will call the vens lab vens action, our vens action that will call vens under the scene with the parameters. This is the latest version of vens CLI, the report, the config file. Here we say that we need attestation, attest true the CycloneDX attestation for evidence and provenance, the LLM provider, and the model. And then here I upload the VEX and attestation. So I can show you this. Yeah, so I already played this job, and the most important, or this pipeline, so the most important job is vens contextual triage. This will trigger vens CLI under the scene. It will first of all load the configuration. This is what you introduced in your config file. Then it will start processing vulnerability from the report, the Trivy report or Grype report that will contain 153 CVEs, and then it will start scoring vulnerability by vulnerability. So for example, for this one, we got 55.2 score with high severity and the vector, and all this is based on your context. It will do the same thing for all severities, and in the end, it will give you the count of all severities that you already calculated. And as I said, I uploaded the VEX. So we'll download this VEX, and I will show you how it looks like. So this is the VEX that is generated by vens. Spec version is a CycloneDX VEX. Of course, it respects the CycloneDX specification. Spec version 1.7. We have the vulnerability here and the affected component for each vulnerability. And for the CVE, we have the score, the severity, the method, the vector, etc. And this is the impacted package, same thing. And we have this here, we have the CycloneDX attestation that will contain the provenance and evidence for each CVEs. So before this, we have the metadata that said that this is generated by vens 040. We have the claims for each CVE. For example, so for this CVE, let's take this one. The target package is this one. This is the reasoning why we got this score. It explains, so low business impact due to lack of direct data breach or compliance violation. So this explains the score and the severity, and then it is linked to the evidence so the evidence is here that will explain the input output. Here we have the generation method, the provider that generated the score, which is Olama, the model, the seed temperature, the prompt hash, input hash, the row response. Here it is based in code 64, and it may contain sensitive data. This is why I said we have to be careful with when sharing this file. So now, where to break the honest part. So the model is confidently wrong on some CVE classes. You have to choose the right model. It's not deterministic, so you have to pin seed and temperature to reproduce the run, and vens help you do this with flags. You have to produce a full context to have an accurate result. It is based on described system, not runtime reachability. So it cannot read things from runtime currently, maybe in the next future. So you have to introduce a full context in the config file. The roadmap, we are currently integrating vens with Dependency-Track to create vens and then upload it in Dependency-Track. The VEX ingestion is merged. Dashboard UI is in progress. We plan to add more scanner, and it's an open source, so your issues and the PRs are very welcome in our repository. The takeaway, so severity is not priority. Very important. Vens here is not shortening or suppressing vulnerabilities. It is using context and LLM to reorder, and you have a VEX that will contain a clean result with all the scores that are generated based on the context, and the CycloneDX attestation that will help you to debug and understand why we have all these values on the VEX. Thank you.